है, so this is our third lecture on classical mechanics and our main focus is to solve different problems on different topics. तो हमारा main focus रहेगा कि हम different problems लेंगे different concepts पे, and that will help you in the different competitive exams, right? So today's topic is about that Lagrangian dynamics, right? So first example जो मैंने यहाँ पे ली है, so as per the example says that the Lagrangian of a particle, हमारे पास एक Lagrangian है having mass m that's moving in a two-dimensional plane. It's moving in some two-dimensional plane, and that Lagrangian is given by this 1 by 2 m x dot square plus y dot square minus this potential term, that's k by 2 x square plus y square. Because we know that तो Lagrangian हम कैसे define करते हैं, that is kinetic minus potential part, right? So this is our kinetic part, kinetic energy, and this is our potential energy. Okay. And now the question says, what question says that if the particle has finite momentum, अगर particle के पास finite momentum होगा about the origin, right? So then we can say that motion is oscillatory or periodic. तो हमें कहना है कि whether the motion for this Lagrangian जो मैंने यहाँ पे Lagrangian लिखा है, तो मुझे कहना है कि whether that motion is oscillatory or periodic about x-axis or along y-axis or about the origin, right? तो वो मुझे देखना है. तो उसके लिए हमें क्या we can use that equation of motion we can solve for this Lagrangian, because Lagrangian हमारे पास है, and so equation of motion हम लिख सकते हैं, that is d by dt of that, take the derivative of this and then partial L by with respect to what, right? So because हमारे पास जो particle की motion जो है, that's the two-dimensional plane, right? So that means we have two variables here. So first, because the particle can move along x or it can move along y direction also, right? So I can rewrite them. So if I solve this, because so from equation of motion I can write that. So we can rewrite that equation of motion for this. So we can write that the equation of motion the equation of motion will be, so that will be simply that partial L by partial x dot or partial L by partial y dot, right? Because I need to calculate first what's our, because our equation of motion is that is d by dt of that partial L by partial r minus partial L upon partial r. So that will be equal to 0, right? Because r is basically, we are basically saying that the motion particle ki hai, it's a two-dimensional plane, right? So it can be along y or along x, right? So that means first I will solve this equation of motion, right? And write what should be our partial L by partial r dot for this, right? तो उसके लिए मुझे क्या करना है? So first, if I calculate what's our partial L by partial x dot and partial L by partial x. So partial L by partial x dot क्या होगा? And similarly, what's our partial L by partial y dot और partial L by partial. तो ये दोनों मुझे कैलकुलेट करने हैं. तो फर्स्ट if I have a look on this equation, तो अगर मेरे पास जो Lagrangian है, so if I, because I'm saying that I need to differentiate it partially, so that means if I calculate my partial L by partial x dot, so that will be only the variable will be here x. So why? Because I am differentiating it partially. So that means, so I will get here that is 2x dot m divided by 2. So it will be equal to mx dot, right? So that means here that partial L by partial x dot will be mx dot. And similarly, when I have look on the Lagrangian, जो हमारा Lagrangian है, so if I calculate now, what should be my partial L by partial x? So that will be equal to, तो यहाँ पे मुझे differentiate करना है partially with respect to x. So that means when I differentiate this term, because I need to differentiate with respect to x, because it's partial L by partial x. So in that case, this will be equal to minus 2kx, and 2 is in the denominator, so I will get minus k of x. So this is for, so for this, when I differentiate it partially with respect to x, and similarly, I will get here my dot and minus ky. Right? क्योंकि अगर हम if you have a look on the Lagrangian, जो हमारा Lagrangian है, तो यहाँ पे because I need to, so this is our equation of motion, right? I need to differentiate partially with respect to that x and partially with respect to y. So that means I will get both the terms, that is partial L by partial x dot and partial L by partial y dot. And similarly, partial L by partial x and partial L by partial y. So I've got these two equations, right? So that means I can write this. I can write that Lagrangian equation will be that is d by dt of partial L by partial x dot minus partial L by partial x. तो ये हमारा कौन सा होगा Lagrangian equation when I take the x coordinate of this. Huh? So that means, and similarly, I have one more equation that is d by dt of that partial by partial y dot minus partial L by partial y. So that will be equal to 0. So that means मैंने already calculate किया यहाँ पे what is my partial L by partial x dot. So that's mx dot. So this is I can write here that is d by dt of that's equal to mx dot minus that's minus kx because this is partial L by partial x of this L. So that's minus kx. And similarly, जो मेरी second equation होगी that is d by dt of that my dot minus ky. So that will be equal to 0. So in दो equations को मैं further लिख सकता हूँ because I need to differentiate it with respect to time here. So first equation will be, so I can write here, first equation will be that is mx double dot plus kx will be equal to 0 and my double dot plus ky that's equal to 0. Because when I differentiate, because mass to particle का constant रहेगा, right? Only you need to differentiate it with respect to x, right? So x dot, sorry. So x dot will be, it will be x double dot. Huh? So if we have a look on this is equation of simple harmonic motion, right? So with that, with that frequency equal to that's equal to square root of k by, because this is x double dot plus that k by m x equal to 0. So that means this is oscillatory motion here, right? So that means I can combine these two equations because this is basically so that जो मेरी equation होगी because my Lagrangian this equation will be that's d by dt of this thing. So that means I can write that इस equation को मैं लिख सकता हूँ that is m of x dot plus y double dot है plus k of x plus y. So it will be equal to, तो इस equation को मैं लिख सकता हूँ that is m r double dot plus k r that's equal to 0. So that means I इसको मैं लिख सकता हूँ. So I can combine these equations. I can get that m or double dot plus kr that's equal to 0. So which is simply that oscillatory motion. Oscillatory motion. Now, because if you check the what was the तो प्रॉब्लम जो हमारी थी हमें कहना था कि जो मोशन यहाँ पे पार्टिकल का होगा तो ये ऑसिलेटरी होगा और इफ इट इज पीरियोडिक नाउ either it is along x along y or about the origin. So that means जब हमने कैलकुलेट किया है यहाँ पे तो ये ऑसिलेटरी also oscillatory motion है but that oscillatory motion is so I have oscillatory motion along x as well as x along y. So that means so this is the oscillatory motion about the origin, right? So that means जो यहाँ पे मास जो पार्टिकल है मास है उसकी जो मतलब ट्रैजेक्टरी होगी so that will be oscillatory the motion will be oscillatory but about the origin because I have the motion along x as well as along y. So this is what basically tells us that whether this motion is oscillatory or periodic about x or y or about the origin. So that means this is oscillatory about the origin. So this was basically our first problem. About this the application of Lagrange, right? So second जो हमारी problem है, so it tells us that अगर हमारे पास if we have a particle of mass m that is constrained to move in a trajectory, that is constrained to move in a vertical plane, तो हमारे पास एक plane है जहाँ पे एक particle move हो रहा है जिसका कुछ mass होगा m and that trajectory is given by the equation. तो इसके लिए equation दी होगी तो that will be x equal to some a cos x equal to a cos theta and y equal to a sin theta. So that means हमारे पास we have this xy coordinate and we have some particle having some mass m, right? तो इसकी जो trajectory होगी because we can write what should be the vertical component. यहाँ पे मैं लिख सकता हूँ vertical component क्या होगा और horizontal component क्या होगा. So it will be this will be a cos theta. So that's x equal to a cos theta. So this is equal to x equal to a cos theta and तो ये जो होगा, सो दैट विल बी y इक्वल टू a sin theta. So that is basically these are motion are given by these equations, right? तो अब हमें क्या करना है? So we need to construct the Lagrangian for this. Okay. So we need to write what should be the corresponding Lagrangian for this. Because when we write the Lagrangian is simply that it is kinetic minus potential part, right? So that means first I need to calculate what should be my kinetic part एंड उसके बाद मैं देख सकता हूँ पोटेंशियल पार्ट. तो अगर हम पोटेंशियल पार्ट की बात करेंगे, यहाँ पे जो इसका जो पोटेंशियल एनर्जी होगा, सो दैट विल बी सम माइनस mgy, राइट? ओके, सो v विल बी इक्वल टू माइनस mgy. हाँ, इट्स वेरी क्लियर डाउन. हाँ, सो फर्स्ट लेट्स राइट व्हाट शुड बी आवर लैग्रेंज. सो बिकॉज वी नो दैट, तो हमें पता है कि जो हमारा लैग्रेंजियन होगा, सो दैट इज t माइनस v. ओके, सो फर्स्ट लेट्स कैलकुलेट व्हाट्स माय लैग्रेंजियन, व्हाट्स माय काइनेटिक पार्ट. तो अगर हम यहाँ पे काइनेटिक एनर्जी निकालेंगे, सो दैट इज 1/2 v स्क्वायर. सो दैट मींस यहाँ पे जो मेरी वेलोसिटी है, जो पार्टिकल यहाँ पे होगा जिसका मास m है, जो इसकी वेलोसिटी होगी, इट हैज टू कंपोनेंट्स. इट कैन हैव vx स्क्वायर एंड vy स्क्वायर. सो दैट मींस इसको मैं लिख सकता हूँ m vx स्क्वायर प्लस vy स्क्वायर. ओके, राइट. और इसको मैं इन टर्म्स ऑफ x एंड y, इसको मैं लिख सकता हूँ x डॉट स्क्वायर प्लस y डॉट स्क्वायर. सो इट्स अप टू यू. Or let's calculate now what is my or you can rewrite this as the kinetic term will be equal to 1/2, that's mx square m x dot square plus y dot square. तो इसको मैं ऐसे भी लिख सकता हूँ. तो that means first I need to check what should be my x dot, because मेरे पास इक्वेशन दी होंगी. x इसका हॉरिजॉन्टल कंपोनेंट क्या है, जो पार्टिकल है, have some trajectory in some vertical plane and x equal to a cos theta और y a sin theta के बराबर है, right? So that means x dot निकालने के लिए I need to differentiate this term. तो इसको मुझे differentiate करना है. तो my x dot will be equal to, you need to differentiate because theta will change and in some constant, because यहाँ पे मैंने लिखा है a some constant, has some constant value, right? It can be some numerical value, right? But only theta is changing here, right? So that means x dot I need to differentiate it with respect to theta, and similarly I need to differentiate y with respect to theta. So that basically gives me x dot and y dot. So that's basically the velocity component along x direction, and velocity component means vertical and horizontal components of velocity. So let's first calculate. So that means in order to calculate that, what's my x dot? Because x is equal to a cos theta and y equal to a sin theta. So that means जो x dot मेरा होगा, so that will be minus a sin theta dot, and जो मेरा y dot होगा, so that will be equal to a cos theta into theta dot, because sin theta की differentiation होगी cos theta और theta की theta dot, because theta is changing, right? So I can write that. So that means जो मेरा x dot square होगा, so that will be equal to a square theta dot square sin square theta, right? And जो मेरा y dot होगा, y dot square होगा, so that will be a square theta dot square cos square theta, right? But मुझे क्या निकालना है? So because I need to calculate what's my kinetic energy, so that is 1/2 mx dot square plus, so that means I need to add these two, huh? So I can write them. My t will be equal to, that is equal to 1/2 m x dot square is equal to a square theta dot square sin square theta plus a square theta dot square cos square theta. So because a square is common, theta square is common, so it will be 1/2 m a square theta dot square into sin square theta plus cos square theta. So that means जो मेरी काइनेटिक एनर्जी होगी, इट विल बी 1/2 m a square theta dot square. So that is t. अब हमें देखना है कि बिकॉज जो मेरा लैग्रेंजियन है, सो दैट इज इक्वल टू काइनेटिक माइनस पोटेंशियल पार्ट. अब मुझे पोटेंशियल एनर्जी यहाँ पे देखनी है. तो पोटेंशियल एनर्जी कितनी होगी? सो दैट आई कैन राइट बाय v, बिकॉज सो लेट अस कैलकुलेट दैट. बिकॉज t2 मैंने यहाँ से निकाला, आई नीड टू कैलकुलेट व्हाट शुड बी v. तो इन ऑर्डर टू कैलकुलेट दैट v, सो so v निकालने के लिए, so that means that will be equal to, v will be equal to mgy here, right? Okay, because only it will be vertical component of that. Huh? Okay, because it will be vertically down. So that means V will be here. I can write that. I can write that V will be equal to that's mgy, mgy. But y is equal to mg a cos of theta. Okay, because that's our V. So that means when I substitute this T and V, I can write that Lagrangian will be equal to 1 by 2 m a square theta dot square minus m g a. So this was basically what we need because तो मैंने आपको कहा कि अगर हमारे पास एक पार्टिकल होगा दैट्स मूविंग इन अ वर्टिकल प्लेन एंड दैट इज गिवन बाय द इक्वेशन x equal to a cos a sin theta and y equal to a cos theta, right? And I need to construct the Lagrangian. तो Lagrangian हमने निकाला. Lagrangian निकालने के लिए मुझे काइनेटिक एनर्जी पहले देखनी थी, उसके बाद पोटेंशियल एनर्जी. So that means that total Lagrangian will be equal to E minus V. So from there I can also write the equation of motion because we can calculate that dl by d theta. So you can calculate the equation of motion. If you are interested, you can calculate what is my d by dt of that partial l by theta, partial theta dot minus partial l upon partial theta. So that means I can calculate this Lagrangian equation from here. Right? But question हमारा कह रहा था कि हमें only we need to construct only the Lagrangian for this case. जहाँ पे particle move हो रहा है in a vertical plane and these equations are given. Right? So these are the two problems on the Lagrangian dynamics, and in our coming lectures we will discuss about those cyclic coordinates, and अगर हमारे पास Lagrangian होगा तो हम कैसे how we can identify these cyclic coordinates and some problems on the central force also, right? So hopefully we will discuss in our coming lecture. Thank you very much.